बच्चों, गुड मॉर्निंग। आज के আমরা শিখব how to fill up the electrons, how to fill up the electrons to show the electronic configuration. Okay, in our previous class we fill up the electrons in the cell, that is K or L or M or N or O. So electrons are filling on K and follows the rule 2n square, right? Suppose K, L, M. So we can fill only 2 electrons. We can fill the K orbitals, K orbit with the help of 2 electrons. We can fill L with the help of 8 electrons. We can fill M with the help of 18 electrons. And it follows 2n square. It follows 2n square. Okay. Now for K, the value of n is equal to 1. So putting the value of n, 2 into 1 square, that is 2 into 1 and 2. So we can write 2 electrons for K. Similarly for L, the value of n is equal to 2. So we can write 2 to square 2 4, that is 8. So we can fill only 8 electrons for L. Similarly for M, the value of n is equal to 3. So 2 into 3 square, 2 into 9, that is 18. So we can fill only 8 electrons for M. But this is not the correct method to fill up the electrons or to show the electronic configuration. For this reason, we have to know about the subset, that is denoted by S, that is denoted by P, that is denoted by D, and that is denoted by F. Okay, so this video is to learn how to fill up the electrons with the help of SPDF. Okay, let's see. So there are 4 types of quantum number. Okay, one is principal quantum number, that is denoted by small n. Another is azimuthal quantum number, that is denoted by small l. Another is magnetic quantum number, that is denoted by small m. And finally spin quantum number, which is denoted by n, small n. What I say? N means principal quantum number. Okay, n means principal quantum number. L means azimuthal quantum number. Okay, so M means magnetic quantum number. And S mean spin quantum number. So N means principal quantum number, L means azimuthal quantum number, M means magnetic quantum number, and S means spin quantum number. So for the electronic configuration we use the term NLMS to find out the SPDF. So to know the SPDF, we have to know the NLMS. Without this NLMS, we cannot understand about the SPDF. Okay, let's go. For K, for K, for K, for K, the value of principal quantum number is equal to 1. Okay, for K, the value of N is equal to 1. Now, the value of L, value of L is equal to 0. Okay, value of L is equal to 0. And the value of M is equal to also 0, because the value of N is depending on plus M to minus M, or minus M to plus M, or L means N minus 1. The value of N is equal to 1, so 1 minus 1, that is 0, and the value of M is depending on the plus L to minus L, plus L to minus L. As the value of L is equal to 0, so the value of M is equal to 0, and the is always plus minus half, okay, plus minus half. So for L, when the value of L is equal to 0, then this is called S. When the value of L is equal to 1, this is called P. When the L is equal to 2, this is called D. When the value of L is equal to 3, then called it's F. Okay. Now the value of N is equal to 1, so this is 1. The value of L is equal to 0, that means S, so this is 1s. And the number of electrons plus or minus half 2, so 1 is 2. So first we get 1 is 2. Now hydrogen, we know the atomic number of hydrogen 1, so we can write the electronic configuration 1 is 1. The atomic number of helium 2, so we can write 1 is 2. Instead of K equal to 1 for K is equal to 2 for helium, instead this type of electronic configuration, instead of we can write this type of electronic configuration. This is the most applicable, most pure electronic configuration. Okay, so this is 1 is 1. Now what is for L? For L, the value of N is equal to 2. So the value of L is equal to N minus 1, that is 2 minus 1, so this is 1. Okay, you got it now? And for M, the value is minus L2 plus L. So minus 1, 0 and plus 1. As the value of L equal to 1, so we can write the value of N equal to minus 1, 0 plus 1. And the value of S. So plus half minus half, plus half minus half, plus half minus half. That means 3 into plus half minus half. That is 6 electrons. Okay. So for 2, this is 2. For L equal to 1, what I say? L equal to 0 means S. L equal to 1 means P. L equal to 2 means D. L equal to 3 means F. So what is the value of L? L equal to 1. So for 1, this is P. So we get 2p, and the number of electrons is 6. So we get 2p6. So what okay. have a correction. For n, the value of n equal to 0 and 1. Okay, so we can divide it into two groups where n equal to 2 and n equal to 0 and n equal to 2, n is equal to 1. For n equal to 0, m equal to 0 and a is equal to plus minus half. Or for m equal to minus 1, 0, plus 1, so a is equal to plus minus 3 into plus minus, for plus minus plus minus plus minus, so 3 into plus minus half. For 2, this is 2. For n equal to 0, this is s, and the number of electron 2, so 2 is 2. And for this 2, as the number of n equal to 2, n equal to 1, that means it is p, so 2p, and the number of electron, so 6, so 2p6. So what we get for k, what we get, n is equal to 1, n equal to 1, so this is for n equal to 0, n equal to 0, m equal to also 0, and s equal to plus minus half. So what we get for n 1 and for n s, for n 0, this is s, so 1 s, and the number of electron 2, so 1 is 2. So what we get, electronic configuration, first 1 s 2, second 2 s 2, and third 2p6. Okay, with the help of these small things, 1 s 2, 2 s 2, 2p6, we can calculate up to number of electron 2 to 4 and 6 10. So we can calculate up to neon. How? Suppose you have lithium. Lithium means 3 atomic number. That means 1 is 2, 2 is not required because here only 3 electrons. So 2 to 4 electrons. 4 electrons, we require only 3 electrons. So you can write 1 is 2, 2 is 1. Okay, for carbon number of electron is 6. So you can write 1 is 2, 2 is 2, 2 is 2, and 2p 2 to 4. So 2 is required. So 2 to 4 and 2 6. For n is equal to 7. So you can write 1 is 2, 2 is 2, 2p, 2 to 4, so 3. So 2 to 4 and 3, 7. So you can write with the help of this for neon. For neon number of electron 10. So you can write 1 is 2, 2 is 2, 2p6, 2 to 4, 4 and 6, 10. So we can write the electronic configuration, or we can show you the electronic configuration through this way. So this is a very easy method to write the electronic configuration. So for what is for KL and what is for M? Let's see what is for M. What is for M? For M, oh sorry, small m, capital M. For M, let's say me, for M, what is the value of principal quantum number? Let's tell me what is the value for principal quantum number for M. For M, what is the value of principal quantum number, which is denoted by N? Come on beta, tell me what is the principal quantum number for M, for K 1, for L 2, for M 3. So the number of principal quantum number 3. Okay, now what is the azimuthal quantum number for this section? What is the azimuthal quantum number? This is 3, principal quantum number 3. So the azimuthal quantum number 1, 2, not 0, 1, 2. If the number of n equal to 4, so we can write 0, 1, 2, 3. If the number of 5, so we can write 0, 1, 2, 3, 4. If the number of n equal to 6, so you can write 0, 1, 2, 3, 4, 5. If the number of 7, you can write the value of n 0, 1, 2, 3, 4, 5, 6. If the value of 8, for the value of 8 for n, if the value of n is equal to 8, so you can write the value of n equal to 0, 1, 2, 3, 4, 5, 6, 7. So here's the value of n equal to 3, you can write the value of n is equal to 0, 1, 2. N is equal to 3, so you can write 0, 1, 2, the value of n. 0, 1, 2, if the value of n is equal to 3. So the value of m, for m, you can divide into 3 groups. Okay. For n is equal to 3, n is equal to 0. For n is equal to 3, n is equal to 1. For n is equal to 3 and n is equal to 2. Okay. For L0, M0. For L1, M minus 1, 0 plus 1. For 2, for 1 minus 1, 0 plus 1. For 2, minus 2 minus 1, 0 plus 1 plus 2. The value of M is between minus L to plus L. As the value of L equal to 2, so you can write the value of M is equal to plus 2 plus 1 0 minus 1 minus 2. Okay, so A is equal to plus or minus of. Here A is equal to 3 into plus or minus of. Here A is equal to 1 2 3 4 5, so 5 plus or minus of. So for 3 you can write is 3. You can write it also 3. You can write it also 3. For L is equal to 0, that means S. L is equal to 1, that means P. L is equal to 2, that means D. L is equal to 3, that means F. Or you have to remember, S contain only 2 electrons, P contain only 6 electrons, D contain 10 electrons, and F contain 14 electrons. This is fulfilled. Now S, the maximum capacity to hold the electron in it, that is 2. So this is the fulfilled, and its half is called the half filled, as 1, 3, 5, and 7. Those are the called half filled, and those are the called fulfilled. Okay. As S can hold only 2 electrons, it's called fulfilled, and the half of the fulfilled is called the half filled. So this is half filled and this is called fulfilled. So how many electrons can hold 3? L equal to 0, yes, 3s. So how many electrons can hold 3s? As it is S, it can hold only 2 electrons. So this is 3s2. Is it clear? Is it clear, beta? This is 3s2. For L is equal to 1, L is equal to 1 means P, that is 3P. Why 3? Because the value of N is equal to 3. So P, for 1 P, so 3P, 3P means P can hold only 6 electrons. So you can make 6, 3, 6. Why 3? Because the number of N is equal to 3. And for L is equal to 2, you put the value of 2 is equal to D. So this is 3D. And how many electrons can D hold within it? How many electrons, beta? That is D means 10 electrons. So you can write 10. So what do you get? 3s2, 3p6 and 3d10. Okay? 3s2, 3p6 and 3d10. Lastly, what for N? What's for N? Let's see what's for N, beta. For N, what is the value of N? For capital N, what is the value of N? That is principal quantum number 4. Okay, this is 4. What is the value of L? If 4, then the value of L is equal to 0, 1, 2, 3, not 4. 0, 1, 2, 3. Okay. Now we can classify into 4 categories, where N is equal to 4, L is equal to 1, N is equal to 4, L is equal to 1, N is equal to 4, L is equal to 2, N is equal to 4, and L is equal to 3. And the M, the value of M is equal to 0 because L is 0. The value of M 1, that means plus 1, 0, minus 1. For M, 2 means plus 2, plus 1, 0, minus 1, minus 2. 3, so plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. Value of S, this is plus minus half, this is plus minus half, but how much? 1, 2, 3, so 3. 1, 2, 3, 4, 5, so 5 into plus minus half, and how? 1, 2, 3, 4, 5, 6, 7, so 7 into plus minus half, that is this. So for n you can write 4, l is equal to 0. Again l is equal to 0 means S, l is equal to 1 means P, l is equal to 2 means D, l is equal to 3 means F. So this is 4S, l is equal to 0, so S, 4S, and S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. So this is 4S, and how many electrons? Plus minus half means 2 electrons. S can hold only 2 electrons. For N this is 4. For 1 this is P, and P can hold only 6 electrons. 3 into plus minus half into 3, that means 6. 3 into 2, 6. For N this is 4. 2 means D. So for D, how many electrons? 5 into plus minus half. So 10, but he can hold 10 electrons. So 40, 10. Lastly, this is 4. For L is equal to value 3. 3 means F. So 4F and 14. So you can write the electronic configuration with the help of this subset. Okay, let's see how. We know now what is 1s, why is 1s, what is 2s, why is 2s. Okay, now we should write the electronic configuration, what our aim is. So now fill up the electronic configuration. Suppose you have sodium, the number of electron is 11. Okay, we start from hydrogen number of electron 1, so you can write 1 as 1. For helium 2, this is 1, this is 2, so this is, you can write 1 as 2. For lithium 3, you can write 1 as 2, 2 as 1. Lithium beryllium 4, so you can write 1 as 2, 2 as 2. Boron 5, so you can write 1 as 2, 2 as 2, 2p1. 2p, how many electrons can hold? 6. So we can continue from here. 6, 1 as 2, 2 as 2, 2 to 4, 2p, 2, 6, 2, 2, 2, 2 to 4, 4 to 6. Nitrogen 7, so you can write 1 as 2, 2 as 2, 2p3. For oxygen 8, so you can write 2p3. So 1 is 2, 2 is 2, 2p4. For fluorine 9, so you can write 1 is 2, 2 is 2, 2p5. For neon 10, so you can write 1 is 2, 2 is 2, 2p6. For sodium 11, so you can write 1 is 2, 2 is 2, 2p6, 3 is 1. 2p6 is the last limit. Okay, then you have to write the next electron for 3s. So 3 is 1. For magnesium 12, so 1 is 2, 2 is 2, 2p6, 3 is 2. 3 is 2 is complete. Then 3p. For aluminium 13, 1 is 2, 2 is 2, 2p6, 3 is 2, 3p1. Aluminium. Okay. Then silicon 14 means 1 is 2, 2 is 2, 2p6, 3 is 2. Then 3p6, 3p1. So you can fill up to 3p6. So 3p2 silicon. Okay. Now phosphorus, phosphorus 14, now 15, phosphorus 1s2, 2s2, 1s2, 2s2, 2p6, 2p6, 3s2, 3s2, 3p2, so there 3p3, phosphorus, that is. Okay, so those are the simple tricks for find out the electronic configuration. Similarly sulfur 16, that is 1s2, 1s2, 2s2, 2p6, 3s2, 3p4, so 2s2, 2p6, 3s2, 3p4. For chlorine 17, 1s2, 2s2, 2p6, 3s2, 3p5. For argon 18, 1s2, 2s2, 3s2, 3p6. So argon is complete. Now potassium for 19, 1s2, 2s2, 1s2, 2s2, 2p, 2p, 2p6, 2p, sorry, 1s2, 2s2, 2p6, 2p6, 3s2, 3p6, 1s2, 2s2, 2p6, 3s2, 3p6, then 4s1, 4s1, then 3d, 4s1 after. For calcium 20, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then for scanadium, scanadium 21, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 4s2, 3d1. Now start 3d1, 3d2, 3d3, 3d4, 3d5, 3d6, 3d7, 3d8, 3d9, 3d10, and so on. Okay, but you have to learn something about this electronic configuration. What should I learn? Let's see, 4s2, 3d1. Why not 3d1, 3d3? Why not 3s2, 3p6, 3d 1, 2, 3, and then 4s? But why the correct electronic configuration 4s2 and 3d1? Then we have to follow the formula n plus l. The value of n plus l for 4s, the value of n is equal to 4 and value of a is equal to 0, that is 4. And for 3d, the value of n is equal to 3, and for d, what is the value of l for d? L is equal to 0 means S, L is equal to 1 means P, L is equal to 2 means D, so the value 2, so 2 means 5. So we have to follow where the n plus L value is less, we have to fill up the electron first for them. So 4s 1, then 4s2. After fulfilling the 4s, we can write 4s2, then 3d1, and so on. 4s2, 3d2, and so on. This is the process to fill up the electrons. Okay. Is there any problem? I think no. So wait for the next video and revise it, practice on it. I hope it makes you easy. It's very important to continue your chemistry because electronic configuration, if you cannot draw the electronic configuration, if you cannot write the electronic configuration, you cannot able to learn the chemistry. So firstly you have to, it is your beginning time, you are the beginner, you are the learner, this is the first, you are the first learner, so you have to learn the electronic configuration first, then you have to proceed this chapter. So this is my atomic structures, electronic configurations, and wait for the next video. Thank you so much, keep studying and take care of your health. Goodbye.